Hello everyone. Today's second speaker is on track 2 is Dragomir Radovanovic. In his talk, Dragomir will focus on the angle of system engineering responsibilities to how they can help data engineers and data scientists. Dragomir is an experienced IT expert working with a diverse set of information systems for over 15 years. For the last 5 years, I have specialized in working with big data supporting, data processing, data management systems. His topic for today is the role of a system engineer in a data-driven company. Hello, Dragomir. Can you continue with your presentation?
Hello, thank you for introducing me. As Vuk mentioned, I have working with various systems for the past 15 years, and for the last specializing in big data supporting systems. I work at Smart Octo. My position is system engineer, and this is what I will be talking about today. So a bit about the company from which I came from, so you can get some background on it. Smart Octo is a company providing analytics mainly for digital publishers. It's a company emerged after two analytics companies joined forces. Smart Octo from Netherlands, which specialized in the real-time processing, and Content Insights from Serbia, which specialized in historical processing. And these systems are actually making two main components of one big system now, and those components are historical and the real-time component. So what are those components? Historical component is crunching data in batches fashion and preparing today's data to be available for tomorrow's reports and insights based on the client's business model. What we do here is translating complex data into actionable insights. The real-time component is actually showing data real-time data about visits, engagement, reach, as well as using those data to enrich client real-time experience. Some of the data-driven features for the real-time component are A/B testing for headlines optimization. This is a feature where you can enter a number of titles for the article and then serve it to visitors using algorithm that runs for approximately 20 minutes. It will decide which title is the winner and which title engages audience the most. Also, if there is a clear winner, the test could run for less than 20 minutes. Another feature are notifications. Notifications are also based on business model and can be delivered on various channels, Slack, email, WhatsApp, you name it. Some of the examples of notification are sleeping story wake up when the old story gets some attention. This article should trigger the paywall. Move this article to your homepage, and this article should be on top in your newsletter in an hour. These are all data-driven decisions based on users on the client's portals. So what is the role of a system engineer in a setup like this? Well, as a system engineer, my responsibilities are bound to two categories, as I see it. Infrastructure and support. Taking care of infrastructure implies taking care about servers, network, storage, service connectivity, load balancing, security, and all that stuff. Basically making sure everything is interconnected and not compromised. Beside infrastructure, my view on system engineering main goal is supporting other teams and answer to their requirements, basically building infrastructure around those requirements. And in short, what technologies do we utilize? From databases, there are Postgres, SQL, Elasticsearch, from programming language, Node, Python, Scala, Java, PHP. From platforms, there are mostly AWS. And that's about it. So what we will focus on today. So focus of today's talk will be data and system engineering collaboration and success stories from the system engineering perspective. It is important to mention that every success story like these that would be in examples has a couple of not so successful stories, because in order to achieve results, sometimes you have to fail and learn from failures and apply that knowledge to make more resilient and robust systems. So now we will focus on how cooperation works in practice through some examples and how they see system engineer role in a company like ours. So since it is a data-driven company, there is a lot of cooperation between data teams, mostly data engineering teams, and system engineering. Usually we have a common goal where I see our collaboration as brain and muscle. Data team, the brains provide pipelines parsing data transformations, while system engineering is there to set up all the tools, including but not limited to servers, permissions, storage, networking, and basically all that is required to make that process smooth and reliable. We will go through some of those examples of those cooperation. Now, in the first example, I will talk about making ingestion component on AWS using its Fargate and load balancer services. As I see it, to build data-driven system like this or similar, there are three main tasks: gather data, transform it, present it. Here we are concentrating on one of those components, and that is the gather data component or the ingestion component part. Ingestion component role is to accept data from client portals and to put it into permanent storage to be accessed and transformed later. It is a crucial component of the system because this is the part of the system that cannot fail, or in case it fails, there is a possibility of irrecoverable data loss, and that is something to really take care of. So basically, how the job is split between teams among other stuff, there is a lot of communication, planning, testing, revealing what are the edge cases in those scenario, and on the way to it getting the best solution. Data engineering team role in this project was actually to make an application that will accept incoming data, and that it will put it to persistent storage for the later transformation and to serve it to clients through our front-end databases. Beside making application, there are some requirements. So basically, the only requirements for this project was to have enough processing power to manage all requests coming in. So since we are publisher-related, we have publisher-related product. Their traffic depends on the time of the day. So the number of requests we are managing also varies depending on the time of the day. So it is crucial to not over-provision or under-provision those resources, especially under-provisioning, because it will lead to sure data loss. One of the other requirements is to be highly available infrastructure, to be self-healed, and to scale depending on the number of requests. And as a main topic or main request is to not lose data. High-level architecture overview of this project was load balancing in front of auto-scaling groups. Load balancer accepts incoming requests and forwards it to the instances in the auto-scaling groups. There, further manage number of instances based on resources or metrics. And not losing data is especially important, as do we not want for application instances which are put out of use to be terminated too quickly before they get a chance to put their data in permanent storage. So we did here that after instance was removed from autoscaling group, we used the AWS's lifecycle hooks to actually keep instance alive for another 15 minutes for it to be able to put its collected data into permanent storage. Many we had some blind spots discovered on this project. Those were mainly when we have surge in traffic, because usually our traffic is steady during the day and it looks something like this. It's very predictable, as we have the same amount of clients during the day. We do not have 50 or 100 clients in one day. So basically it's pretty predictable, but some events, for example, like this Corona situation, or when there are some big publishing pushes or big articles, there are some surges in traffic. And at first we had issues on autoscaling with that because the autoscaling groups we utilized do have a cooldown on the upscaling. So we needed to take a new approach there and to see what is the best way to scale our infrastructure. Basically, we come to a solution where we scale our traffic based on traffic instead of just focusing on the resource usage. So we shifted from resource usage tracking to target tracking, where the scale out is performed based on metrics. So that's one example. The next example I have in mind is automation. Enabling other teams to utilize automation tools and to make it accessible to them is also one of the aspects of the job. So if someone wants to deploy a new version of software or to test or to put it into production, they should not depend on anyone if it is possible. Maybe you develop at 10 p.m. and you want to see your work in test at that time, or something like that. And this is where automation takes a part of enabling us to enable other teams, in this case, data engineering teams, to deploy their version of software where they need it, where they want, when they need it, and to do test and to check out how it works, and to continue their work uninterrupted by waiting for someone of system engineering team to show up online, or to wait tomorrow's day to actually check with some of system engineering guys to actually do the updates and run the required procedures. One of the cases where this is also a great solution is when you need a hotfix required for proper functioning of the production stack. Someone should be able to deploy it without waiting for other people. This is quite a large topic, and there are many ways how we can improve speed of development by enabling automation for other teams. Another example is database management optimization. This is where, let's say, data teams create schemas, decide how data is stored, and what are actually the base requirements for the system. While system engineering duty is to make some optimization to provide the best ratio of functionality versus costs. Optimization are crucial to best performance of the hardware without the need to over provision and generate additional costs. So, and another example of this cooperation is storage management. Storage management is actually crucial when you have terabytes of data coming in daily. You want them to be stored at the best possible price, and yet to other teams to have access to them when needed, and to be able to transform data when they are required to. So data teams are the one who knows how long data should be kept, because they know the whole life cycle of what happens to data in our system. So data teams are the one who knows how long data should be kept and who should be able to access it. On system engineering team is to make lifecycle policies that will expire data when it's needed, and access policies which will allow access based on required permissions. The expiration, of course, is done to prevent expenses when they're needed, or when the data lose its value, or when it's already transformed and put into some of the front-end databases, and they will be kept for the amount of time that is required by retention policies, or how long the clients need them. So basically, in this case, expired data that is removed from storage is already transformed and has reached some of the databases where it will be kept according to that policies. So keeping data in control is key to being efficient and cost effective. So how do we ensure we have the best cooperation, and in what ways we can influence each other workflows? From the system engineering point of view, constant communication, being involved in the actual development process, so that we know the requirements, know what to expect, and to actually being able to foresee what is coming up. That are our requirements from data engineering teams, and we are here to offer automation and to help others by making some tools to help teams bring their ideas to life faster. For me, as a system engineer, it is important to constantly evaluate and reevaluate such processes and cooperations. This way, we make sure that the job is easier for everyone. We get the best out of us, and we can rely on each other by making such amends. So, what are my expectations in the future? How this will evolve further? But, well, as I mentioned, making more tools and automation from system engineering teams will help others make best use of their time, and to focus on the stuff they really do, and they do not lose time about setting up some server or deploying code to some environment which maybe is somewhere, I don't know, it does not matter where, but it will require also sort of privileges to be set up for that to work correctly. So to finish it off, what I see as the most crucial thing in cooperation is the actual communication and teamwork. This happens to be the key to all projects, all cooperation, and all actually successful stories. This is the key point. Okay, basically this is it. I will finish with this.